Okay, so we added and subtracted radicals, we multiplied radicals. Now we're going to learn how to divide radicals and rationalize the denominator. We'll talk about what that means. First, dividing radicals, very similar to multiplying radicals in that you don't have to have those like radicals like you have to have when you add and subtract. Multiplying, dividing, you don't need the like radicals. So here's a division problem. 2 radical 90 divided by radical 18. We're going to write it on so that this is the numerator and the denominator, a bit a little easier to see. 2 radical 90 over radical 18. That's the same thing. Okay, you know that that's division. All right, so we're going to divide. There's really a 1 there, so 2 divided by 1 is 2. And then 90 divided by 18 is 5. So it's going to be 2 radical 5. That's got to stay under the radical because it was radical 90, radical 18. You divide the radicands. So divide the coefficients, divide the radicands. Keep whatever is under the radicands, keep it under the radical as the new radicand. And that's that, okay? It's that simple. Now, when you have a binomial, radical 80 minus radical 5 over radical 5, you just have to realize that the radical 5 divides into both of these. So this can be written kind of like doing a subtraction problem backwards, okay? This can be written as radical 80 over radical 5 minus radical 5 over radical 5. Just splitting it up because, again, that's what would happen if you had a subtraction problem. You would combine the like terms, or combine it into one fraction with a radical 5 denominator. So this is the exact same thing. So now we have radical 16 minus radical 1. And of course, radical 16 is just 4. Square root of 16 is 4. And the square root of 1 is 1. So 4 minus 1, and that is 3. Okay, so you get 3 there. Here, divide, okay, so 4 radical 2 divided by 2 radical 2 plus 8 radical 12 divided by 2 radical 2. So that's going to give us 2 radical 1 plus 4 radical 6. 4 and then radical 6. All right, so then this is just 2 times 1. Radical 1 is 1. Square root of 1 is 1. So it's 2 plus 4 radical 6. Got to make sure it's simplified as much as possible. That would be our final answer there. And then this one here, oops. Divide is just the single radical, so everything gets divided. 108 divided by 6, that gives us 18. So this will be radical. It's only going to be one radical. 18, and then a to the third, subtract the exponents, b to the sixth. Remember, when you divide, you subtract the exponents. All right, so this breaks down on, this is 9 times 2, and then that goes down to 3 times 3. Okay, so that becomes, there's our pair of 3's there, right there. Left over 2. This is A, B, 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 B. Okay, so we have a pair of A's, pair of B's, pair of B's, pair of B's. There we go. We have 3 A, and then 3 pairs of B's. That's B to the third, and then radical 2A left over. We have an A left over here. All right, so 3 a to the third, radical 2b. So once you divide, this is just simplifying like we did in the other lesson. Consider this example, radical 7 divided by radical 2. What seems to be the problem here? Well, the problem is, hopefully you see, that 2 does not divide into 7 equally. So 2 doesn't divide into 7 equally. An equal number of times. 2 doesn't go into 7 an equal number of times. Okay? So that's where this rationalizing comes from. How do we handle that? We still have to be able to do it. So this is called rationalizing the denominator, and there's a couple different scenarios. The first scenario is how to rationalize with a single radical term. a single radical term in the denominator. So that's like these examples here. You just have radical 5 over radical 3. This is radical 5 over radical 3. How do we handle that? 3 doesn't go into 5. This is the way we're going to handle it. We need to get the denominator to not have a radical, because you can never leave a radical in the denominator that's considered like not being in simplest form. We talked about this a couple lessons ago. We talked about simplifying radicals, and we said we would leave this particular condition or scenario for this lesson. Well, now we're there. You cannot leave a radical in the denominator. So what do we have to do? We have to come up with, we want to get a radical that we could take the square root of, a perfect square. So how do you do that? Well, just use the radical itself. Radical 3. What can I multiply by? Because remember, you can multiply by whatever you want, as long as whatever you do to the bottom, you do to the top. What can I multiply by to make it so that I don't have a radical in the bottom anymore? Well, if it turns out if you multiply by itself, okay, radical 3, that would give me radical 9. All right, so whatever you do to the bottom, you do to the top. I'm going to multiply both the top and bottom by this radical, radical 3. So that's going to give me radical 15 over radical 9. But I still have that radical in the denominator, but it's a square root. It's a perfect square root. Square root of 9 is 3, just 3. You know, you can break it up, right? 3, 3, and there's my pair of 3's. Okay, or you can just do square root of 9. Square root of 9 is 3. All right, so that's going to be square root of 15 over 3. And you're done. So now what we've done, in that simplest form, we've gotten that radical out of the denominator. Now, it made the numerator more complex, or a larger radical. That's going to happen. We don't care about that. It's the denominator. You do not leave radicals in a denominator. That's important. All right, so here we have radical 2 over radical 3x. So again, we want to get this to be a perfect square, so multiply by itself. We don't care about the top. Whatever's there is there. It's the denominator. Because now I have square root 9x squared. That's perfect square. This is square root 6x. And then this simplifies to 3x on the bottom. Square root of 9, square root of x squared. Okay, just by simplifying it down by our methods that we learned in another lesson. A couple more here. Now this one here, you could do radical 8, by all means. You could do radical 8, radical 8. But you actually only need to do radical 2. I want to show you this, because this is going to help you with the next one. You really only need radical 2. Where did I get that from? Well, I know that by doing radical 2 times radical 8, that's going to give me radical 16. And square root of 16 is 4. So the radical will go away. If you did radical 8, it would work. You would get radical 64, and that would still go away. Your radical goes away either way. Whatever you do to the bottom, you do to the top. However, obviously, the larger radical you multiply by, the larger your numerator is going to get, then you're going to have to simplify. So it's up to you. Whatever you can see, whatever comes to you, that works. But radical 2 is good enough here. So this gives me 3 radical 16 for now. And then this is 2 radical 10. So now I get 2 radical 10 over 3 times 4. This is a 4. Radical 16 is a 4. So it's 12. And then 2 over 12 reduces. So I get radical 10 over 6. The 2 over 12 is really just a 1 over 6. So radical 6 over 10, I'm sorry, radical 10 over 6 would be your final answer there. Now, cubic root's a little trickier. So this is cubic root 5 over cubic root 9. Now, cubic root 9 is not a perfect cube. You can't take the, because it's 3 times 3, right? Well, 3 times 3, you need, if it's cubic root, you need 3 of them. So cubic root 9 doesn't simplify. What you need to do is, because it is 3, 3, that shows you all you need is another 3. So if you multiply by cube root 3 here, and whatever you do to the bottom, you do it to the top, I have a 3, and a 3, and that's going to become that is a perfect cube. So this is cubic root 27. Again, that's going to simplify. And then this is cubic root 15, which I don't really care about. I'm just going to leave that the way it is. And again, 27 is 9 times 3, and then 3 times 3. So there's my, see how it comes down to just one group of 3's? And all right, so that just comes down to, that just becomes a 3. So it's 3 cubic root 15 over 3. That would be your final answer for that problem there. 3 cubic root 15. I'm sorry, just cubic root 15 over 3. That's the cubic root symbol. Cubic root 15 over 3. All right, so here we have fractions we're adding. We want to add them, but we need a common denominator, so we're going to go times 2 and then times 2. So this is going to give us 2 radical 90 plus radical 5 over 2. And radical 90 can be simplified. I can do 9 times 10, so I can do, well, I'm just going to do it on the side here. 9 times 10, and then 3 times 3. The 9 breaks down 3 times 3. So that's going to be a 3. Times the 2 that's already there, that's going to give me 6 radical left over 10 plus radical 5 over 2. So this is just about finding a common denominator there. This one's a little trickier. All right, so we have 3 radical 3 minus radical 3 over 2, because square root of 4 is 2. Put this over 1. And then this is 1 over radical 3, because radical 1 is just 1, and then radical 3. Now here's the problem. We have this rationalizing we want to do here. So we're going to multiply by radical 3 over radical 3. So we have 3 radical 3 over 1 minus radical 3 over 2 plus, now we have radical 3 over 3. Okay, we rationalized our denominator, and now we're ready to combine. We're ready to combine. We need like terms, or like denominators. We need a common denominator here. So we're going to go times 2 here, times 2, times 3, and this one needs times 6, times 6. All right, so now we have our common. All right, so we have 18 radical 3 minus 3 radical 3 plus 2 radical 3. 18 minus 3 is 15 plus 2 is 17. I have 17 radical 3 in my numerator, and of course just over 6. So a combination. Rationalize. Once you have that rational denominator, just get a common denominator and add them up, which we've been doing. You already know how to do that. That was just a review problem part there. Okay. So now before we get into our other more complex denominators, I want to just a quick review here of what happens when we multiply conjugates. This is from our multiplication lesson. We already know how to do this. So 2 times 2, that's 4, and then minus 2 radical 5, and then this times this, distributive property, 2 radical 5, and then radical 5 times minus radical 5 is negative 25. So what happens? Well, what happens when we have conjugates is this and this becomes a 0 pair. It reduces to 0. So we're left with just 4 minus, this is just 5, and that's a negative 1. So what happens when we multiply by conjugates is we no longer have a radical, because 2 of the radicals became a perfect square and the other 2 reduced to 0. Every time we have conjugates, this is what happens. We talked about this already. All right, so how to rationalize with binomial denominator. We're going to, when we get these binomial denominators, see how the denominator is different. We have 5 minus 2 radical 3, 4 minus radical 11, radical x minus 3. We have binomial denominators here. What you need to do is you need to multiply by, not just the radical, you need to multiply by the conjugate. So it's 5 plus 2 radical 3. 5 plus 2 radical 3. All right, so that's going to be, and we have to distribute. So now you're just multiplying radicals on the top and on the bottom, which we already should know how to do. The top's going to be 5 radical 3 plus 2 radical 9. over, and then 5 times 5 is 25. And then negative 2 radical 3 times positive 2 radical 3 is negative 4 radical 9. Now we're going to simplify. This is 2 times 3, so I have 6 plus 5 radical 3 over 25 minus, now 4 times radical 9 is 3. This is 12. 4 times 3 is 12. 25 minus 12 is 13. You should be able to do that in your head. 4 times 3. 4 times 3 is 12. 25 minus 12 is 13. And that's it. 6 plus 5 radical 3 over 13. Here's another one. Multiply by the conjugate. 4 plus radical 11. That's for the denominator. Whatever you do to the bottom, whatever you do to the denominator, you have to do the same thing to the numerator. 4 plus radical 11 up here. All right, so now multiply on top, multiply on the bottom. The bottom's actually easier because they're conjugates. So it's just 16 minus 11. That's what you're going to end up getting. You should already know the shortcut by now. The numerator's tough because you have to distribute. So you get 4, and then you get 1 radical 11 and 4 radical 11. So it's going to be 5 radical 11 total, and then plus 11. Radical 11 times radical 11 is just 11. So you end up getting 15 plus 5 radical 11 over 5, and then you can simplify this because 15 over 5 is 3, and then this is a 1. So 3 plus radical 11 would be your final answer there. Almost done here. This one's got an x in it, so what? Same process. Multiply by radical x plus 3. Radical x plus 3. Put this in parentheses here. All right, so my denominator's easy. It's going to be radical x times radical x is x, and then negative 3 times 3 minus 9. You get x minus 9 for the denominator. The numerator, you have x radical x, and then you have plus 3x, and then you have minus 9 radical x, and then you have minus 27. And there's not much you can do here. You don't have like terms. None of these are like terms. So what we can do is we can only take this down, try to factor by grouping here. We could factor this by grouping. We could take out an x here. So if we take out an x, here, we have radical x plus 3. And then if we take out a negative 9, we have radical x plus 3. That's over x minus 9. And of course that goes to x minus 9. You have a common denominator, radical x plus 3, x minus 9 over x minus 9. That reduces to 1, and you're left with just radical x plus 3 as your final answer. I know that one's pretty crazy. We'll go over that one again tomorrow if you're having trouble with that. And then this one here this one's a little different. This one is not a binomial. It's all under the radical, so you're going to treat this one as if it's one of these guys, okay, where you're just going to multiply by the radical. It just so happens that the radical is a binomial, so you're going to multiply by radical x minus 3, literally what you see. All right, so you get, here you can't distribute through a radical, so you're just going to get x minus 3 times radical x minus 3. And then here you get any radical times itself is whatever's underneath. So really, you just get x minus 3. Anytime you multiply a radical by itself, like radical 11 up here, radical 11 times radical 11 is just 11. So radical blank times radical blank is blank, just x minus 3. Oh, look at that. Reduced to 1. So I'm left with just radical x minus 3 as my final answer. Got a little crazy at the end there, I know. Again, we're going to practice these and work on it and get a little better in class tomorrow. You're not expected to be an expert right now. You're not expected to really understand, but all you're expected to really do right now is be able to come into class and at least set up multiply by the radical, multiply by the conjugate, whatever the scenario is. You should at least be able to do that. I'll see you in class tomorrow.